In experiment 9, we learned how we can construct a balance, and we actually used it to show that air has weight. Let's see if we can take our balance now and answer the question, are some molecules heavier than others? What we want to do is actually weigh the difference between a collection of two different molecules. And we're going to try to weigh the difference between a collection of air molecules and a collection of carbon dioxide molecules. Now, what is air? Well, air is made mostly of nitrogen molecules and oxygen molecules. If you had 100 air molecules, you'd have roughly 80 nitrogen molecules and about 19 oxygen molecules. So air is mostly nitrogen. Now, here's our balance that we're going to use to actually weigh the difference between a collection of air molecules and carbon dioxide molecules. Each bag now contains a collection of air molecules. Each bag is the same size, so we have the same number of air molecules in each bag. So we want to make sure that our balance is level since each bag weighs the same. In experiment 7, we learned how we can make a collection of carbon dioxide molecules by mixing baking soda and vinegar. Now, we want to fill this bag up with carbon dioxide molecules, so we're going to need to make a lot of carbon dioxide molecules. So let's make our carbon dioxide in this big bucket. What we're going to do is we're going to take about a cup or a cup and a half of baking soda, and that's about a cup and a half, somewhere around there. And let's just sprinkle the baking soda in the bottom of our bucket. And now let's add about 2 cups of vinegar to our baking soda. And when we do this, a chemical change is going to occur between the vinegar and the baking soda to produce our collection of carbon dioxide molecules. Okay, let's let the bubbling stop, and when it does, I will then transfer or pour the carbon dioxide gas that's in this bucket into this bag. And then we'll see what happens to the 2 levels of the bags. Okay, so here we go. Now, watch to make sure that I don't transfer any liquid into the bag because we're comparing gas molecules. All right. Let me swing this around here. Let's look at the levels of our 2 bags now. This bag contains a collection of carbon dioxide molecules. This bag contains a collection of air molecules. This bag is lower than our bag over here. So what does this observation tell us? It tells us that carbon dioxide molecules are heavier than air molecules. Okay, we just showed that carbon dioxide is heavier than air. Let's have some fun with this experimental result. What I'm going to do is fill this plastic bucket up with some carbon dioxide molecules, and then I'm going to blow some soap bubbles into our collection of carbon dioxide molecules, and let's see what happens. To make our collection of carbon dioxide molecules, I'm going to take some baking soda again, about a cup and a half. I'm going to sprinkle it into the bottom of the bucket. And I'm going to take 2 cups of vinegar, and I'm going to add it to our baking soda. There's our 2 cups. And you'll be able to see the chemical change that occurs between the vinegar and the baking soda. Carbon dioxide gas is being produced, and that's why we see the bubbling. Now I'm going to take some soap bubble solution, and I'm going to blow some soap bubbles, and let's see what happens when some of the bubbles go into our bucket. Okay, as you can see, the soap bubbles don't fall all the way to the bottom of the bucket. Now, how can we understand this? Well, we learned that carbon dioxide molecules are heavier than air molecules. So what the carbon dioxide molecules are doing in the bucket, they are pushing up or supporting the air molecules that are in the soap bubbles. This is why the bubble just sort of hangs in the bucket. All right. Let's see now if we can take this experimental result and explain why a balloon filled with helium atoms wants to go up. Here I have two balloons filled with helium atoms. It turns out that helium atoms are lighter than air. So the helium balloons want to go up because the air molecules around the balloons are supporting the helium atoms in the balloon or pushing up on the helium atoms in the balloon.